you can ask him all about it.
Yeah, great talk. Thanks for presenting a lot of intuition. Can you recap again on the POR? Is POR kind of like sending, or what's the?
So POR encapsulates a number of functions. It includes sending your ZeroCash coins to someone else. It includes making change, say taking one coin and splitting it into two, or conversely merging two coins into one, so you can set it in a single transaction. It just for convenience and generality, we capture this using a single general transaction type. Curiously, because it's merging to a single general transaction types, when it happens, then people who look at the ledger have no idea which one it was. So just taking two Satoshis and merging them into one locally looks the same as paying 1 billion Satoshis to someone across the internet. It just pseudo random record in the ledger.
If you pursued the implementation where you sort of piggybacked on the existing Bitcoin implementation, would the value of a unit in ZeroCash be pegged to the value of Bitcoin, or would
So if things are implemented the way I described, then yes, you have you have precise one-to-one pegging simply because you can freely convert one to the other. Alternative mechanisms using altcoin mechanisms would have different dynamics, of course.
To be clear, there's a difference between sort of two-way pegging where you have a new currency running on top of it versus where, say, hypothetical words declare remodified Bitcoin, so it inserted all these bits. If you did the latter, you'd end up with that. If you did two-way pegging, you'd also end up with it, but if somebody increased it, well, okay.
Right.
Will LibSnark be free software? Will it be sort of unencumbered? I ask because I know that there's like Pinocchio and the Skipper group are sort of competing implementations of Snarks. I'm more familiar with Pinocchio, but the Bitcoin developers, I think I rightly said that it's kind of a non-starter because the kind of release conditions of it say that you can't use it for applications resembling Bitcoin. So I wonder if LibSnark's going to be completely different.
We are well aware and supportive of the Bitcoin's community preferences for liberal open source licenses and intend to follow it.
Cool.
So on that same topic then about your source code, have you investigated the export information? Like anybody, no government agencies pinged you about cryptography exports? I don't know. Maybe you're familiar with this. Like, it's got to be a topic among cryptographers about export stuff.
So export controls are a complicated affair. I am not a lawyer, usual disclaimers. It has been a while since a cryptographer, especially academic researcher cryptographer, or I should qualify that more precisely. It has been a long while since academic cryptographers encountered any problem of that sort. It would be very amusing if that monster rears its head again. It would be especially amusing given that this is an international collaboration.
Right.
I'd like to see them try.
Oh, okay. But I have a bunch of questions. I don't want to stop anybody.
Go, put offline.
Go. Well,
No.
I don't know.
I'm curious.
Okay, so it seems you talked about Bitcoin there several times, but I guess, you've talked about also releasing this altcoin. So I guess a lot of times when you're talking about Bitcoin, you're meaning your non-anonymous currency. So
Right.
anyway, I guess maybe there should be another name for that if you're using ZeroCash as the anonymous currency or the anonymous version. And I guess kind of a separate question is how separate are they? I'm guessing they would be, let's say you're spending ZeroCash. I mean, you could spend either one, is that right? I mean, maybe I'm a little bit fuzzy here. I mean, is there So let's say you build, I mean, you're talking about building an altcoin, right? Using the Bitcoin library. And so I think that your vision is two currencies, an anonymous and a non-anonymous currency. Is that right?
So let me answer first your first question. I use Bitcoin for concreteness, but as I said in an early slides, all we use is the Bitcoin-like ledger structure and transaction structure. In particular, all I said applies to almost any altcoin currently in existence. As for which currency to use, so if we go for the hybrid approach, we end up with a free one-to-one conversion bidirectionally between the public Bitcoin or other altcoin currencies and the privacy-preserving, anonymized ZeroCash ones. Which one will you use? Well, you're at liberty to convert from one to the other, so this will be a practical affair. If you're paying a legacy merchant that only accepts old Bitcoins, you will have to use your stash of Bitcoins or convert your ZeroCash coins into Bitcoins. If you're using a modern, privacy-aware merchant, you do the other thing. You could be maybe under some compulsion or regulation to use one or the other. It becomes another degree of freedom, but what I hope to see is people protecting their own privacy by using the privacy-preserving one as a matter of course.
Okay. Go ahead, please.
You mentioned government being able to regulate the taxing of transactions, and to my mind, it seems like that would only work if we had a world government or a government that agreed on international law how that was going to be done, because there's no possibility of knowing where the transactions are happening between citizens of which country. Is that right?
So the question is, if you want to apply regulation and you use it at a national level, how can you enforce that on a system that is inherently international? Well, you could couple this into national PKI schemes. For example, you could have you could have smart cards containing a certificate specific to citizens, like there already are in various countries, and e-cards, passports, and so on. And that will identify you as a citizen of country X. And the predicate enforced by the ZeroCash successor would say that if that every wallet should have a certificate properly signed by a national authority in order to be accepted by designated merchants, or in order to make it past choke points in the economy, like conversions into local currency. You can imagine a lot of integration going through PKI and certificate infrastructure to express external physical world or national legal world properties within the cryptographic predicate.
Would users of ZeroCash, just for back from an ambitious and interesting question to a very basic and mechanical apologies. So if I understand things right, the core operation is kind of the heart of things here, where a user does a pour and it doesn't reveal anything about whom or from or whether things are being merged or paid, but it's visible that something's happening, right, on the network. Would users have to be careful about not falling into certain habits of timing, like immediately upon having received, somebody pours somewhere else and somebody pours here, and an agency watching the network draws inferences about, oh, that looks like it might have been a transaction between those two parties.
That's a good question. The question was whether timing analysis and traffic analysis are still possible. If you see correlations between transactions, it may imply something. So in particular, if you only had 3 people in the universe and you see a transaction broadcast on the distributed ledger by Alice, and a second later you see another transaction broadcast on the ledger by Bob, you can be pretty confident that it was just Alice that sent something to Bob and Bob received it and did something about it. That's true. That is inevitable for the current ledger systems. And the way you would fight it is through generic countermeasures against such traffic analysis, for example, the Tor network.
There was earlier some talk about 288 byte proofs, but you're mentioning 1 kilobyte here. I just wondered if you could kind of comment on that.
So 288 bytes is the size of the snug proof at 128 byte security level for best proofs to date, the paper you pointed out earlier. The rest of the overhead is outside of the snug proof itself, but rather the serial numbers and the destination address for the public value, the various fields I showed in the big table. And actually, just by looking at the table and counting characters, or better yet, by looking at the paper that has an explicit figure showing precisely this, you can see where the costs lie and which optional components can be turned off if you are very demanding about transaction sizes.
Okay. So you had a figure, your last table, it might be still there if you, I guess we're not seeing it there, but you talked about this long list of fun.
Oh, this one.
Of fun things there. Cheap verification, Turing complete scripts, blockchain compression. So I'm just curious, how close to being available those are. For example, the blockchain, I'm slightly fuzzy about this blockchain compression. One of the big problems in all cryptocurrencies is the requirement that every node process every transaction. And I still haven't quite figured out. My understanding was that there's a way to use skip to solve that problem. Is that correct?
Just one guy will do the computation and then just publish this. Not everyone.
That's my understanding. And so rather than every node doing every node repeating the transactions, one guy would do the transaction. He'd publish his zero knowledge proof that he had done it. The other guys could just verify the proof rather than repeating the transactions.
So, there are different ways to implement it with different trade-offs. You're right. There are variants where nobody ever looks back at the history, and actually every transaction has just a local proof generation associated with it that basically increments an incremental proof that summarizes the whole state of the world to date. So in those variants, nobody ever needs to see the whole blockchain.
Okay, so I guess a little bit. So these things that you listed there, the blockchain compression and the Turing complete scripts, I guess is there a lot of work? Maybe it's a very open question, but I'm just wondering, is it like 2 months of your PhD guy's work, or is it like a year? Or I don't know how big of a deal it is to do some of those things that you described right there.
So there's a combination of factors here. One is just figuring out what's really needed, what are the problems that need solving. Then you figure out whether they can be really expressed as formal statements of the kind that can be proved by SNARs. And then you figure out whether the state of the art in snark technology can support them.
Okay.
So, for example, blockchain compression requires snarks that look at themselves at at least the simple version of blockchain compression requires snarks that themselves look at the whole blockchain and summarize it. So, given the current overhead of snarks, this would be extremely expensive. Right now in the lab, we're building a more powerful version of the snarks called proof-carrying data that give you that incremental property. Using this, you could imagine doing blockchain compression much more feasibly. So most of these applications, I would say, will be at the very least pushing the state of the art in snark technology. But the good news is that once we know what they are, once we figure out what are the really exciting systems to build, we can also tailor the snarks and find the application-specific shortcuts that make things more efficient, as we did, for example, with ZeroCash.
Could you briefly go back to the slide before this and the one you skipped over about this one? Just quickly describe it.
Okay. This is a brief discussion of trust assumptions. I'm comparing here three systems. Just the simplest mixing we described at the very beginning of the talk, where you trust someone. There's an operator that you have to trust. You have to trust them for